Today we're going to take a look at 1.9, which is scientific notation. It will have a little bit of what we've been doing with exponents in it. That's why we need to look at the exponents component of this idea before we got to this lesson. And there is a portion of this that I teach a little bit differently than you may have seen taught before. If you're good with what you've taught before and you're always getting them right with your method, whatever, that's great. But give me a chance to show you what I do with this and see if it helps. And if it's not, that's fine. And if it does, that's fine too. So to start with, scientific notation. The basic form of scientific notation is that it's a times 10 to the n, where a is between 1 and 10. There's actually should be some absolute value signs here, so a could technically be negative for the purposes of what we actually really do with scientific notation. That's pretty uncommon, but it could be. It's important that n is an integer. Okay, so positive or negative, but whole numbers, right? Positive or negative whole numbers. And we're going to talk about moving in both directions. So the first slide talks about taking standard numbers, that's numbers that you have been working with so far, and turning them into something that's in scientific notation. So what we're going to do is we're going to move the decimal point to create a value between 1 and 10. And we'll count the number of times or how many moves we made. What you see listed below is where things are a little different than maybe you've seen them before. Your exponent will be positive if the number itself was large, and by large I mean larger than 10. And your exponent will be negative if the number is small, namely smaller than 1. Okay? So sometimes people talk about, like, did you move it left or right, and that determines whether it's positive or negative, and that's okay. But what you have to understand is that it depends on which direction you're actually talking about. Did you start in scientific and you're turning it into standard, or did you start in standard and you're turning it to scientific? And that changes whether or not you're thinking about it in a positive, negative, left, and right. To me, that starts to sound a little bit messy, because we can always talk about a positive exponent meaning a large number and a negative exponent meaning a small number. So let me do a couple of examples with you. The first one is 298,000. Now, there's not an actual visible decimal point here right now. So where is the decimal point? That's where we want it to be. We'll get to that in just a second. But where is it right now actually? Yeah, it's at the very end of the circle. And you are already answering for me, Caleb, where do you want it to be? Right, so we want it to be here. Okay, so we're wanting to move it from where it currently is, which is at the very end of the number, so that we create a number between 1 and 10. That would be 2.98. And we're not going to round things off. We're just going to put it inside of there and keep all the digits that there are that are non-zero. And we're going to count. So I moved it 1, 2, 3, 4, 5 places. So the number I have is 2.98 times 10 to the power of 5. And then I need to decide if the 5, because that was 5 moves, is positive or negative. The original number was 298,000. Is that number big or small?
Big.
It's big. Okay, remember big just means bigger than 10. It's definitely a big number. So my exponent would be positive, because the number is big. So this is scientific notation for 298,000. All right, on the next one, we actually see the decimal point. It's already in the problem to begin with. Where do we want our decimal point to actually be, though? Yeah, between the 3 and the 8. And we want it to be there because that will create a number between 1 and 10, 3.8. So we're going to count how many places we moved our decimal. So this is 1, 2, 3. That's 4 decimal places. Moved it 4 times. So this is 3.8 times 10 to the 4th. Was the original number small or big? Small. So will my exponent be positive or negative? Negative. And I'm done. That's how it works. So now we're going to go the other direction. Are you ready? All right, so we're going to take scientific notation. So something that's already in scientific notation, and turn it back into standard notation. So we're going to move the decimal point the number of places indicated by the exponent. So if the exponent's 5, we move it 5. If the exponent's 12, we move it 12. If the exponent's positive, the number gets big. It's larger. If the exponent's negative, the number gets small or smaller. Okay, so let's take a look at a couple examples. I don't know why I liked the exponent 5. It's used it twice now, but I have. All right, so the 5 tells me I'm going to move the decimal point 5 places. It's negative, so will the number get bigger or smaller? Smaller, so the decimal point moves to the left. So right now I have the number 3.2, and I'm supposed to be moving the decimal point this direction. That's one place, but I need to move it a bunch more, so I need some zeros in front. So here's 2, 3, 4, and 5. So that means I need a decimal point, I need 4 zeros, and then 3, 2. Negative exponent, small number. All right, my next one, 6.24 times 10 to the third. The 3 tells me I'm moving the decimal point 3 places. Will the number get bigger or smaller? Bigger, because it's a positive 3. So right now my number is 6.24. If I'm going to make it get bigger, I have to move the decimal point to the right. So that's 1 place, 2 place. That's not enough. So I need a 0 here to move it a 3rd place. And the number I end up with is 6,240. Okay, positive exponent, ended up with a big number. They go hand in hand. All right, any questions on those? Okay, there's one more thing that we're going to take a look at in this section, and this has to do with what happens when we're actually making calculations in scientific notation. So the directions tell us to calculate the following, and then the last piece of information tells us that our answers should be written in scientific notation. Now sometimes when we do the calculation, I end up with an answer that's already in scientific notation, and sometimes I don't. Okay? So on the first one, what we notice is we have 2 scientific notation numbers that are being multiplied. We have this wonderful property in multiplication that allows us to move numbers around. It's called the commutative property. Y'all remember that one? So because I'm allowed to move the numbers around, what it means I can do is I can multiply the 8 times the 6, and I can multiply the 10 to the 12 times 10 to the 15th. Like that. It's great facts. Because what is 8 times 6? 48, right? And then what is 10 to the 12 times 10 to the 15th? You add the exponents, right? We just did a whole couple sections about that, right? So if I add those exponents, what do I get? Yeah, 10 to the 27th. Now, I am not done. Why is this problem still incomplete? It's not in scientific notation. Can you tell me, Malik, why? There's a fly flying around up here. Can you tell me why it's not in scientific notation? What fails? Yeah, so the 48, that number is bigger than 10, right? There's no decimal point in that number, making it between 1 and 10. So I actually need to change this value into a 4.8. Agreed? So the decimal point was understood to be at the end of the 48, and I'm moving the decimal point 1 place. All right? Now, obviously, I can't just move that and leave this 10 times 10 to the 27th. I changed something, and something had to change in order to, something has to change in the 10 to the 27th to reflect that I changed the 48 into 4.8. So I moved it 1 place. So what do you think is going to happen to the 27? It's either going to become 26 or 28 because it changes it by 1 place. Which way do you think it might go? 28. And it's going to become a 28 because the original number was a large number. 48 is large. So the exponent needs to become larger in order to compensate for the fact that I changed something large, 48, into something smaller, 4.8. Once I'm at this point, it is in scientific notation and I am done. Okay, is everybody good with that? All right, let's try another one. Again, I can change the order of the multiplication. The commutative property says I can do 1.2 times 9.5. And I can do 10 to the negative 2 times 10 to the 12th. So, grab a calculator if you wish. What is 1.2 times 9.5? Yeah, it's 11.4. And then 10 to the negative 2 and 10 to the 12th give me what? 10 to the 10th, that's right. That is not in scientific notation, though. Why? Yeah, it's higher than 10. You got it. That 11.4, I have a decimal now in the number. Well, I didn't actually have that in the last one visibly. But it's still not between 1 and 10. So I need my decimal point to be where, actually? Yeah, between the ones, right? I need my decimal to be 1.14. So what's going to happen to my exponent now that I moved it? I'm going to add 1 to it. Lots of ones in this problem. 1.14 times 10 to the 11th.
Are you getting that one extra one because you moved one spot?
Mm-hmm,
Okay.
exactly. If you were to have one where you multiplied enough things to have to move it 2 places, you'd add 2 or subtract 2 from the exponent, depending on how it shifted it. You're right. Most of the ones I think that you encounter, maybe all, only move it 1 place, though, so you don't have to do too much to kind of keep that clear. But it is because it's moved 1. All right, I have 2 more examples, and I want to throw one in as an additional at the end because I realize after I sometimes create my problems that I didn't do an example of something that is actually a little bit different. So let's do these 2 next. They are division questions, but I can treat them much like with my multiplication questions where I can do it sort of pairwise. I can do, that's a terrible color for this. Let me change my color. How about yellow? I can do the 8 and the 2 first. What's 8 divided by 2? 4. And then I have these powers of 10 I have 10 to a power rather, right? 10 to the 4th and 10 to the negative 6th. And I can do just like I did in the previous section where I can subtract exponents. So this is 10 to the 4th minus negative 6. So what is 4 minus negative 6?
10.
Yeah, it's positive, so it becomes 4 plus 6 or 10. So that actually is in scientific notation.
You add more or subtract?
Well, we subtract, but I'm subtracting a negative right here, and subtracting a negative becomes positive. Yes. Another way you could think about it if you wanted to, that doesn't involve that method, is that you could simply move the 10 to the negative 6 up, which makes it 10 to the positive 6, and then add exponents. You could do it that way as well. All right, so our answer is 4 times 10 to the 10th, and it's in scientific notation, so we're done. Number 8's a little bit cleaner. What is 9 divided by 2? That part's not as clean, but 4.5. The part that is clean, of course, is the 10 to the 8th and 10 to the 3rd. So if I subtract exponents, I have 10 to the 8 minus 3. What does that give me? Yeah, 4.5 times 10 to the 5th. Also in scientific notation, some good to go. Now, I'd like to do another example, so we'll just call it example 9. You can just write it in underneath that. And I'm going to change it. We're going to do 2 times 10 to the 7th over 8 times 10 squared. I guess that'll be fine. Component-wise again, but this time 2 divided by 8 is not a whole number or a decimal like the last one number. What is 2 divided by 8?
What?
That's 8 divided by 2. Close. What is it? 0.25. In particular, it's not a number between 1 and 10. That's why I wanted to show you an example like this, because I didn't have one yet. This is 2.5. I'm sorry, 0.25. And then I have times 10 to the 7 minus 2, which is 5. So I have 0.25 times 10 to the fifth, 10 to the fifth. 0.25 is not between 1 and 10. I need to move the decimal over, so it should become 2.5, right? So what do you think it is? It is 10 to the fourth. So this is the first example I also want to show you because I hadn't done one where your exponent actually got smaller. And the reason it got smaller is because 0.25 is a small number. It's smaller than 1. So my exponent needs to become smaller to compensate. Does that make sense? Fabulous. All right, go ahead and get out your homework number 9 for scientific notation. You should be able to finish it in class today, and then you won't have any homework for this evening. Won't that be nice?